Hi guys, this is Denis Magda of GridGain. Let's see how we can use tracing to troubleshoot performance issues of our distributed systems powered by Apache Ignite. Imagine that you've got a cluster of Ignite, and there is an application that is connected to this cluster. The application is running some distributed operations, and then suddenly you detect a performance degradation, and it's unclear where is the root cause. The performance issue might be on your cluster side, or your application might be responsible for this slowdown, or the root cause of this performance degradation might be somewhere in between in your network. To answer this question precisely, we are going to use the new tracing capabilities in Ignite and GridGain Control Center to track the execution times of our distributed operations across all the participating members in our distributed system. Alright, but before we can tap into the traces, we need to configure the OpenCensus tracing module for Apache Ignite. How do we do that? It's all simple. Make sure that in your PAM.xml file or in your libraries list, you have Ignite OpenCensus module. Also, whenever you use GridGain Control Center, make sure that you've got Control Center agent included to the list. And after that, the other final configuration parameter, you need to enable OpenCensus tracing SPI for your Apache Ignite configuration. That's it. After that, whenever your applications will be executing distributed operations and you detect any performance degradation, you will be able to enable tracing and pinpoint a bottleneck. In my case, the application executes distributed transactions over a 2-node cluster that is running locally on my laptop. The cluster is already connected to GridGain Control Center, and this is my application. So next, let's go to the tracing screen. So here, as you can see, the history of the traces I collected before, but as of now, the tracing is disabled. But let's imagine that we are experiencing some performance degradation with transactions. What do we do next? Let's go and configure enable traces for our transactions. I will be capturing 30% of the traces for all of the transactions. Enabled. Now let's wait. Let's give some time to the cluster and GridGain Control Center to collect traces. Okay, you see that the new traces are appearing here. I just need to refresh the screen. Good. On average, it takes like 5 or 4 milliseconds to complete a transaction. Let's select any of these traces. So here, as you can see, that a transaction is a multi-step operation. Usually the transaction starts on your client side, on your transaction coordinator, and then whenever you run commit message operation, the commit will be split in 2 phases. That's how two-phase commit protocol operates in Ignite. There would be a prepare phase, and then at some point there would be a commit phase. So here is what can we see. Once your application executes the commit command, our application will send this request to a primary node, and that's the idea of the primary node. The primary node will be processing this prepare request, and at some point in time it will forward a similar prepare request to the backup node. And this is what happens here. And take a look at the timing. So 4 milliseconds, that's the total execution time. And then you can see like where the rest of the time is gone. It took us only 1 millisecond to execute the commit on the application end, and the rest of the 3 milliseconds, they are contributed by our primary and backup nodes. And that's the useful information we want to have. Imagine that this transaction was running, let's say, for like seconds, and it was not clear who is guilty for this slowdown. And with traces, with these timings, you will be able to identify the root cause easily. Also, what we don't see here right now is if there is any issue in the network, and we can enable networks and add the networking information into the traces of our transactions. How do we do that? Again, we are returning to our tracing screen, and here is you can include communication as an extra scope to the traces of your transactions. All right, enabled. Now let's wait while Control Center collects new traces, refresh the screen, and select this one. Like, oh, it takes more time to execute transactions right now. Okay, so here is if I unfold the same steps, somewhere here, you can see that the new spans appeared. And so here is you can observe how much time it was taking to execute, socket operations like reads and writes. In my case, as long as the whole cluster is running on a local laptop, there is nothing, to worry about in case of the network. That's why the network does not contribute to the total time. But anyway, whenever you will be running in distributed environment, this information also would be useful. Okay, once you are done with the troubleshooting and you identified your root cause, don't forget to go ahead and disable your tracing, because you don't want to capture all this information all the time, only whenever you need it. All right, that's how it works, and make use of it in your production environments. See you soon. Bye bye.